I have been working on a series for taking and passing the CSWP, but I've had a subscriber reach out to me and ask about the Rafael series. They desperately need some moving flaps on their model, not sure how to do it, and they're new to the assembly environment. This is not trivial to make an assembly out of, not as easy as other parts, but I want to do my best to answer their question. And I'm going to try to do the easiest way possible, which I think is through multi-body modeling. I initially tried to make a separate part file and import a flap, but the geometry is just a little bit too complex to make sense for making flaps on this. So let's try a multi-body modeling method, which has some pros and cons, but it is quite simple. And to do that, I just want to cut out these flaps and make this a separate body from the plane, right? So we're going to make the flap one body and the plane another body. We're going to make them separate entities. And to do that, let's go with the top plane. Let's create a sketch. And all I really have to do is, probably the easiest is this outer flap here, 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 and convert entities. Yeah, that should do it. The next thing I want to do is an extruded surface, right? So if you've never worked with surfaces before, this is an infinitely thin thing that is not the final model. It's just a way to create something to reference off of. And it has many, many uses, but I'm trying to be simple here. So let's go in another direction. So I've got this surface that I can kind of drive through my wing, but not intersect with anything else. There, I've got it. And also from the last video, I've changed the geometry of these things just to be a little bit further forward so they don't sit on the back of the wing. So go ahead and edit that sketch if you need to. This is also going to be downloadable from GrabCAD, so you can just download this if you want to as well. I'm going to say OK. So I've created a surface that kind of separates the flap from the rest of the part. It's like a little boundary. Next thing to do is I can choose the split. I just type in split into my commands, make sure that that is the black with the little caret, and I choose split. And my tool is going to be my surface that I've just used, and I have all bodies selected, so I choose cut bodies. And now I check both bodies, and I split them. So I use this surface to make the flap one body. Whoops, I don't want to delete that. And the body of the plane, the other body, right? So I'm going to go, I have here two solid bodies. This is now one body, and this is now another body. They're two separate parts. And if you're new to assemblies, this is not typically how you make assemblies. This is a different way to make assemblies that's more complicated. But for our purposes, this is more simple because of the complicated wing geometry that we have. So now I want to delete my surface. So I go to delete body, click on my surface, make sure that that's checked, and delete my surface. So now I'm working with two bodies, and I can hide one body. Right? I can take this plane straight, hide it. Next thing to do, sketch on this face, and I can choose this point, and this point, and this point, and I can choose this kind of spline entity and make it tangent, and then draw a line from here to here, right? I want my flap to have sort of a rounded leading edge. Next thing that I can do is select this surface, and I guess exit my sketch, and then select this face, sketch, here, here, and here. We can go tangent and draw a vertical line, right? Fully defined, closed entity. I can say features. When I get out of my sketch, I can choose boundary boss, or you can do a loft, either way, loft or boundary. And we've created sort of this rounded leading edge on our flap. Bam, there we go. So now I can show the rest of my plane. And if you're astute, you'll see that these surfaces, or these bodies rather, are intersecting, right? So that leading edge that we just made is now interfering with the wing. And so I want to make sure that I hide my body and kind of provision my plane to accept that flap. So highlight my surface, we're going to hide it, and now I can sketch on this face, sketch, and I want to do largely the same thing. Maybe I'm going to add in a line. Oop, oop, come on. Here to here we'll go tangent, and here to here. That should work. We're going to make these equal. This is just, they're still going to interfere at the very ends, probably, but this is just a little exercise in trying to get some clearance for the flap to move. Of course, if this is a real plane, you have to have a lot more attention to detail. This is just an exercise. We'll give that 10 thou, of course, because there's a lot that we need to change if this was a real plane application. This is mostly about sketching from an image and how you can make complex geometry from 3 pictures. Okay, we'll go with a vertical. And it's kind of hard to see with the paint job that I've chosen, but you can kind of see it there. And we should have a closed sketch. So we will rebuild. Let's do the same thing on this face, right? We're going to make a little cutout for that flap that we just made to fit into. Sketching on this face. Actually, I want to do the same thing with my straight lines just to create a little bit of clearance, or at least, at the very least, the illusion of clearance, because I'm not really being very thorough here. We're going to make this equal. We're going to make a 3-point arc. Merge. From here to here, we're going to go tangent. 0.01. And there we go, right? So we're going to features, boundary cut, or you can do a lofted cut. I guess it doesn't really matter in this case. They're very similar when you just have 2 sketches. And we're going to cut that out. And we failed to merge the newly generated body with the work piece. That is awfully strange. Let's try a lofted cut from here to here. There we go. So I just unchecked merge tangent faces, and that went right through. So now I have a cutout for a flap, and I have a flap to put that in. Next thing that we want to do is figure out the best axis that this flap can rotate on. So I'm going to, again, create a sketch. This time the intent is to be a reference sketch on this face. And let's create a point. And there's probably a more efficient way to do this with a 3D sketch, but that's okay. We're going to go concentric. And we're going to go sketch on this face. We're going to go concentric over here. This advantage to use a real arc on this because now we can reference off of that arc's geometry. And now I can say 3D sketch, and we're going to make a 3D line from one point to the other, right? So that's ostensibly a good axis for the flap to be able to rotate around. So we're going to rebuild that. Yeah, you know what I'm going to do? I'm going to edit my sketch. I'm just kind of coming up with this on the fly here. And I'm going to make another line that is on the y-axis, right? You can see that little y relation. So we're going up the y, and you only need 3 points to make a plane. And we know that this plane is going to be pretty reliable. So I'm going to make a plane. I know this is taking a lot of reference geometry. And so we know that this plane sits on this line. So now if I sketch on the plane that I just created, Actually, you know what? I'm going to use some lines so that I know that it acts the way that I want it to act. We're going to go with collinear here, parallel, right? So that these two lines are parallel with this line, that the axis of rotation that we want to revolve the flap around, and 0.15. And this can be an arbitrary dimension, right? So if I choose this dimension, 0.01, that's too small. 0.1. There we go. I'm going to say features, revolved cut. We're going to revolve around this. And you can kind of see what I've done, but it looks like I'll just have to make a little extension on this. And for the sake of time, because I don't want this video to last 2 hours, will I obsess over every little detail. Again, I'm trying to get an effective answer fast to this person. We're going to go collinear, collinear, and we're just in empty space with most of this sketch, so I have the luxury of saying equal, parallel, right, we're fully defined. Now let's exit the sketch. So that's a hole, right? That is a cylinder that we can rotate the flap around. From here, I'm again going to draw my own rectangle, and this time I'm just going to make it in 2 parts and adding my relations. Collinear, we're going to make all of these parallel. We can make this 0.1, I guess. Looks a lot bigger on that flap. Make this vertical. Can make this perpendicular. And we might as well make these equal and vertical. Alright, so that, what length are we doing? Maybe this 0.15, I guess, is fine. Alright, so we're going to say features, revolved cut, and, right, so there's our other cylinder that we're going to be revolving around. And these two cylinders share the same axis because I reference this line for both cylinders. And so you can rotate around both of those cylinders. So the next thing that we can do, and I'm going to hide this plane, now I can hide my sketch, and I can hide all my little references that I've made. Okay. So we're going to hide this and show this. And you know what? I think I actually need the reference sketch that I had made. So we're going to actually show that. And the plane that I drew that sketch on is going to be here, so we're going to show that plane. So we're going to create a sketch on this plane. And I'm going to create a little cylinder feature. We're going to make sure that this is collinear, parallel. We're going to get rid of that horizontal so we're not over-defined. And if I go normal, since this cylinder is not equal to that wall, I think what I'll do is actually get rid of that constraint and stretch this line across. So for diameter just 0.1, we can throw in a little bit of clearance here, and we can actually would prefer to dimension it this way. Let's go with 0.9, right? We'll give it maybe 0.09. I guess that's the dimension that I had. And I don't need to go very deep in. Maybe something like 0.1, 0.05. Again, there's not much design intent between these dimensions. Maybe 0.02, so it goes out a bit further. Features, revolve boss base, just like that. I don't like that little pointy tip there. That means one of my lines was vertical and it shouldn't be. So we'll hurry and make that perpendicular, and that should even out to a nice flat cylinder, just like that, right? So that's our axis that we'll rotate around over here. Then we'll rotate our flap along. We'll sketch on the same plane up here. Doing the same thing. Maybe I'll start over here and get smart, so I have fewer sketch entities to keep track of. And I drew them right off the bat perpendicular. One of the many examples of how when you do multiple things multiple times in CAD, you can get better with every iteration. So we'll make that 0.2. We'll make this overall length 0.25 or something. We don't have to go that deep. We'll do the same clearance. 0.9. Well, I guess it's 0.09. That's better. And then, where else are we not constrained? Oh, okay, we got to be collinear. Add in a collinear here, and we're fully constrained. Features, revolve boss base, and there's the axis that we rotate around for that flap. I'm going to hide this plane, hide our reference sketches. So now we have a flap, and if I show my plane's body again, we have a flap that's a separate body to the rest of the plane, but it doesn't move because this is all a part file, and stuff in a part file is not meant to move or be dynamic. It's not how we work, but you can see that we have a little bit of clearance for this flap to rotate around. So how do we make this move? What I'm going to do is save my bodies. So I'm going to take, let's say, my first plane body, and we're going to say Insert, Features, Save Body, right? So we're going to take our plane body and save it to its own file. Again, this is not typically how assemblies are done, but with the complex geometry, this is probably the easiest and quickest way to get something that actually fits, at least somewhat, and get it into an assembly. So this is a little bit more complicated than a regular assembly, but it's something that's a little bit more realistic if you're going to do this for school or for a project or something. So I choose, let's go with this body to save out, and save it out. Alright, so there's my first body, but you can see it just jumped back to the part that I was saving. Alright, so now I want to save my flap, so we'll go to Solid Bodies, and we're going to choose this, Insert, Features, Save Bodies. And we check this flap and simply save. Yes, we will convert the units. And there's our flap. Next, I will, how about I close this down, close that. I'm going to open up the plane body that I just saved as its own part. Right, so that's our plane that we made without the flap. You'll notice a few things. We've lost all our colors. And the next thing, we don't have a history tree, right? This is a dumb solid now. So if you need to change this, you change the part that you saved from, and it should update over here. So now I'm ready to insert my flap, and that's as simple as going into Windows Explorer and dragging and dropping the flap from where I saved it. And now I want to make sure that this flap is positioned correctly, so I have to add mates, which dictate the relationship that parts have between each other in assemblies. So maybe the first thing I can do is select this point, and I say I want this point to lie on this face. So I can say mate, and notice it has the point that I've selected. I choose this face, and now it makes sure that this point is going to stay like on the plane that this face creates, right? So I can move my flap around and that point stays put. Next thing, I want to put this peg inside of this hole. And that's a little bit crazy, but I can adjust this. So now I have a moving flap. Now you can see assemblies aren't that smart in the sense that they don't detect when one body collides with another. For that, you have to go to move component, and then collision detection, and then it says that it's already in a colliding state because we don't have the clearances that we need. But that's how you do collision detection. Anyway, it'd be nice to be able to limit the angles that these flaps are in, maybe plus or minus 10 degrees. All right, so because you want to not have these things collide, an easy way of doing this is with planes. We can limit the angles of this flap. So first off, we can choose this plane and say assembly mate, and we can choose this plane, and we can establish a relationship. Right now SolidWorks wants these planes to overlap with each other or be coincident, but that would lock the flaps from moving. So instead we're going to go advanced mates, and I can choose this little angle symbol, and I think what we can say is something like 10 degrees at the maximum angle. I guess I do have to say 170 degrees and 190 degrees. So I have to make this 170 because the smaller number goes down here, right? So our minimum is 170, our maximum is 190. And that's to say that our planes are constrained to that degree angle and they won't move past that. There's a few things that need to be updated that I think are kind of going outside the scope of this video. Update this so that you don't have interference here, and make this face come a little bit shorter. Just do like a little cut on this face and a cut on this face to make it shorter on both sides, and of course stop this face from interfering at the bottom. An easy way to see if things are colliding when they shouldn't is if we go to evaluate interference detection, and if we calculate, it shows us places where two bodies are interfering with each other, right? So this body is inside of this body here, and we have an interference up here. And so you can run that interference detection to see if any parts are colliding when they should not. So address those issues in your parts, and you should have moving flaps. I hope this video was helpful. If it was, please subscribe, and I'll see you in the next one.